Hello class, we are going through the lecture 31, least squares. I'm your instructor, Ms. Laura Lowe. It will be our last lecture in Module 11. In Module 11, the first thing we talk about the linear association. We use the correlation coefficient to measure the linear association. From that, we will have a linear regression line that will reflect the prediction of the numeric variable from the other. So in today's lecture, we will summarize our linear regression. We will find the best linear predictor. We use the method of the least squares. Beginning of today's lecture, let's quickly review the linear regression we talked about in lecture 30. If you remember, in lecture 30 at the end, we talked about linear regression. We focused on the two numeric attributes, x and y pair. They both convert from the original unit to the standard unit. So remember the linear regression line we present in the lecture 30. We are already convert the two numeric attributes into the standard unit. So from this scatter plot on the standard unit, we can find the regression line with the equation like this. So the regression line will have the estimated y, of course, in standard unit, will equal to the correlation of the x and y times x standard unit. So from here, you will see the correlation R represent the slope of the regression line. And they don't have intercept. If you remember in algebra, when we talk about a straight line, the equation will be y equal to mx plus b. So the m represent for the slope. So in our regression line in standard unit, we do have the slope. And the slope is the correlation of the two numeric variables. However, we don't have the intercept. On the other hand, we mean the intercept equal to 0. So why that happen? Why when we using the standard unit, when we have the regression line, they don't have the intercept? Now you can pause the video, think about that. To think about what is the reason and discuss with your peer. So then here that we'll see why about that. So remember, when we have the original unit, we did do something to convert to the standard unit, right? So remember, whenever we have the original unit, we always minus the average, then divide by the standard deviation. So for example, if we have the x value, we're using the original unit in x value minus the average of x, divide by standard deviation of x. So the same thing, we did that to y. So on the other hand, we kind of shift our original scatter plot to the standard unit. Even the distribution, they still look very similar. However, the coordinates already change. So on the other hand, when we convert the original unit to the standard unit, we have the 0, 0 origins is the average of the x and average of the y. So that's why the regression line always passing through the origin in the standard unit. On the other hand, they don't have the intercept. So that's the reason when we have the linear regression, when we talk about in the standard unit. So that's why our regression line always have the estimated y equal to the correlation times x. But be careful, the x and y here is in standard unit. So in the real life, if we don't want to change to the standard unit, how we get our regression line from the original unit? In order to get a regression line for the original unit, actually what we can do is we just convert back. Remember earlier we say y equal to, when we have the standard unit, the y actually is convert from the original y minus the average of y divided by standard unit of standard deviation of y. So the same thing, we just need to convert back. So on the other hand, you have your regression line in the standard unit is y equal to correlation times x. When we convert to the original unit, we just need to have our standard unit y plugging back to the original formula. We convert from the original y to the standard unit y, right? So here is the standard unit y. So on the other hand, when you x in the standard unit, where they came from is using the original x value minus the average of the x value divided by the standard deviation of x. So the same thing, when you have your estimated y, that will equal to, and here be careful, this y is original unit y minus the average of the original unit y divided by the standard unit y. So that will be the regression line equation for the original unit. And from here, your regression line will be, we used to learn from in the algebra. Remember our straight line, we have the y equal to the slope times x plus the intercept. So on the other hand, can we find the slope? Can we find the intercept? Right, so to find the slope and the intercept, we just need to play with the algebra for this equation, right? And we just need to multiply by that, and then we fit this equation into our y equal to the slope times x plus intercept. So this one, actually, you can see, just like earlier we say, so y, the regression line in the standard unit, we don't have intercept. We just, using the original unit, we shift them with the average x and average y, standard deviation x and standard deviation y. So that's why we have the standard unit. So when you want to find the regression line in the original unit, we just need to convert back. Okay, so after we convert back, that's how our regression line. So here just we talk about the procedure, how you convert back from our regression line in the standard unit to the original unit. So the same thing, after you convert, you will have to predict y using the x. So how to do that? Actually here, I kind of, you can do that by yourself to apply the algebra concept. But if you want to refer to, so here, this one actually is what I already wrote that to show you. So after you convert this original function, so this original function actually came from here. Yeah, remember we're using the standard unit y equal to the correlation coefficient times the standard unit x. So using this equation, then we can get our slope and intercept form for the regression line in the original unit. So the estimate y equal to the slope times x plus intercept. The algebra you can refer to the next page. So I will just skip here. So after we convert that equation to the y equal to mx plus b equation, then we'll get the m slope equal to r times standard deviation of y divided by standard deviation of x. And also the intercept of the regression line will be the average of y minus, actually it's the whole thing here, so that we just say minus slope times average of x. The slope here is the correlation coefficient times standard deviation of y divided by x, standard deviation of x. So from here, did you think about from your lecture 30 at the end, actually, we quickly to find the regression line for our family height example. And I finished very quickly at the end to find the regression line. So we just get the intercept and the slope. So I'm not sure, did you feel very confused last lecture at the end, how we got that slope and intercept? The reason actually is our family height, we didn't convert to the standard unit. We're still using the original unit. So that's why the slope and the intercept, how we calculate from, get the slope and intercept is according to this equation. Yeah, so here, after you get this equation, make sure if you're not sure, it's good to always just work on the algebra by yourself. So then you will see how they came from. But now let's go to our demo in lecture 31. So in lecture 31 and 30, I didn't talk about in the last lecture. Actually, from the beginning, we list some important function that's actually just help us how to make the graph. So you don't need to worry about that. But if you are interested about how in lecture 30 and 31, we get that, like for example, the R table, how we get the correlation, then we have the 1000 pair of the coordinates to make the scatter plot. So that's all came from here. Okay, so then actually for today's lecture, we also add a few more function. So please make sure you will run every cell before we really see the example. So that's why here, the same thing for this lecture, we still need the standard unit function. We still need the correlation function. So that's how we get. And also in your demo file, you will see we ask you to fill up the function implementation for the slope and the intercept. So that's here, I already fill up here. So basically, the slope is earlier we talked about. So this slope we need is for original unit. Okay, so for the original unit, our slope, according to the table you provide, in the two attribute you need. So then we will see the slope. Remember our slope earlier we showed you, that will be the correlation times the standard deviation y divided by standard deviation x. So that's how we can have the function implement like this. We can call the correlation function and using the np.std standard deviation function to get the standard deviation. The same thing, the intercept is earlier we show you. So the intercept for the regression line in original unit will equal to the average of y plus, sorry, here should be minus, will be the average y minus slope times the average x. So that we get the function filled up here. So then you can see here, after we have these two function implement, okay, so then we just see example. Before we show you, you can have your correlation coefficient value. So you plug into the R table, they will give you 1000 pair XY. So then we can have the scatter plot. So after we have the scatter plot, so from here, before we show you the scatter plot, but then let's see again, since we have the slope function, then you just need to plug into the slope function. We check again. So that's why you can see here, after you have this table, okay, so you will see the slope you get. Supposedly should be 0.5, right? But because our R table is, we random generate that. So the slope you get, they will be very close to 0.5, but not exact. Or you can try other value. For example, we change to the R equal to 0.75. So the same thing, you can see the slope will be close to the 0.75, but not exact. Okay, so the reason is, this one is we show you the table include 1000 XY pair according to the R, the value, correlation coefficient. So then from this scatter plot, we can plug in back to our slope function. So then you can get slope. So this slope will be very close to your R value. Okay, so here you can try more. So if you're interested about that, we also can see we try the negative value. Okay, so you can see they are very close but not exact the same. Okay, so the next one, actually, I want to go back to see, again, we go back to see our family height example I showed you at the end of the last lecture. But here, since the video is about 15 minutes, so I will show quickly in the next video.